Hello, everyone. My name is Matt Barrett, and I manage the Flood Management Division of the San Jacinto River Authority. We are pleased to present to you our Spring Creek Flood Control Dam's feasibility study, and we thank you for your interest. First, I'd like to start with a brief bit of background on the study. The origin of the study can be traced back to the San Jacinto Regional Watershed Master Drainage Plan project, an effort led by the Harris County Flood Control District with partners SGRA, the City of Houston, and Montgomery County. The Master Drainage Plan studied the upper San Jacinto River Basin, or essentially the entire area that flows into Lake Houston, which is an area of nearly 3,000 square miles. This study developed models to help predict flood risks across this large area, and ultimately resulted in the creation of a comprehensive flood mitigation plan, including 16 recommended regional projects, which you can see on the exhibit to the right. These 16 projects included 2 flood control dams in the Spring Creek watershed. The first of the 2 locations identified for a flood control dam was along Birch Creek, which ultimately flows to Spring Creek. The master drainage plan estimated the dam on Birch Creek would have an inundation area of roughly 900 acres during severe rainfall events, would remove over 800 structures from the 100-year or 1% annual chance floodplain, and would reduce the total instances of flooding by over 1,000 across a 50-year period. The dam was estimated to cost between $80 and $120 million in 2020 estimates, and had a benefit cost ratio between 0.55 and 0.83. The range of costs, and therefore ratio of benefits to cost, was based on different land acquisition estimates for the 100-year storm inundation area and the PMF inundation area, which I'll explain a bit more on a later slide. Regarding benefit cost ratios in general, a score of 1.0 or higher, meaning the dollar value of expected benefits from a project is equal to or greater than the cost of that project, is typically desired. The second recommended dam was along Walnut Creek, which also flows to Spring Creek. This dam was predicted to have an inundation area of up to almost 1,300 acres, to remove roughly 1,200 structures from the 100-year floodplain, and to reduce 50-year instances of flooding by over 1,600. The cost was estimated at $97 to $132 million, and the benefit cost ratio range was a bit higher than Birch Creek at 0.77 to 1.04. The feasibility study we're currently performing is a continuation of these recommended projects from the San Jacinto Master Drainage Plan. In order to take the next steps on the recommended dams, SGRA applied for and was awarded $500,000 in Texas Water Development Board Flood Infrastructure Fund grant fund. SGRA was also able to partner with the Harris County Flood Control District, City of Humble, and 5 Woodlands area mud districts to provide up to an additional $500,000 in local matching funds to complete a $1 million feasibility study. SGRA is providing project and grant management services, as well as in-kind staff time, to facilitate the study and reduce the local match commitment required of the local funding partner. This study is an excellent example of multiple regional entities working together to address flooding issues. The San Jacinto Master Drainage Plan only included a very high-level analysis of the recommended flood projects, and the scope of this study includes several items aimed at further evaluating the feasibility of the 2 dams recommended in the Spring Creek watershed. These efforts include environmental due diligence via field investigations, desktop survey and analysis, and coordination with appropriate regulatory agencies. It also includes conceptual analysis of the dams, including sizing, configuration, location, and geotechnical soil analysis. And finally, includes updated modeling and benefit cost ratio analysis. The results of the study will be summarized in a final report, including recommendations for potential future phases. Ultimately, the study will determine whether the proposed dams are cost-effective, impactful, and feasible flood mitigation projects which should be pursued to design and construction. If the study finds that one or both dams are feasible, the project sponsor and ultimately owner of the dams would have to be identified to obtain funding and lead future project phases, including design, permitting, land acquisition, and construction. That covers at a high level the background and goals of the study. So now I'd like to talk a bit about the design of the dams and results of the study to date. This exhibit shows the initially proposed footprints of the dams and their locations within the Spring Creek watershed as a whole. Zooming in first to Birch Creek, you can see the initial inundation areas based on the results of the master drainage plan that would be anticipated during a 100-year or 1% annual chance storm event in yellow, and during a probable maximum flood or PMF event in brown. For those of you not familiar, PMF is a hypothetical flood event that can be expected from the most severe combination of rainfall and runoff conditions that are reasonably possible in a drainage area, and these conditions are considered when sizing dams. Both dams are proposed to be dry bottom storage, meaning they would remain dry most of the time, unlike a water supply reservoir such as Lake Conroe, and the land upstream of the dams could be left more or less as is. And this slide shows the initial inundation areas associated with the Walnut Creek Dam, again with the 100-year limits in yellow and the PMF limits in brown. The dams would work by holding back most of the water flowing down Birch and Walnut Creeks during storm events up to a 100-year intensity rainfall. And then these flows would pass slowly through culverts or outlet pipes installed through the dams. Some flows during extreme storm events exceeding the 100-year storm intensity would flow over the spillway. Ultimately, the dams would reduce the amount of water flowing down Birch, Walnut, and Spring Creeks during storm events, mitigating flooding downstream. Unfortunately, once we started the study, we ran into a few challenges. The first challenge was being unable to obtain right of entry to perform the field investigations planned as part of the scope. Compared to the other two challenges I'm going to discuss, this was relatively minor and can be overcome by doing geotechnical work along a nearby TxDOT right-of-way we believe is close enough to provide valid results, and performing desktop-level environmental survey only. So this issue, while unfortunate, is not a deal breaker for the project. The other two challenges are more complex, and the project team has been and will continue working to address them. The first is that the updated modeling done as part of the study showed less anticipated benefits and therefore lower benefit cost ratios than were estimated in the master drainage plan. If you recall, the benefit cost ratios coming out of the master drainage plan were already just at or below the desired 1.0 level. To address this issue, the study consultant has worked to optimize each dam, reducing the dam sizes as appropriate based on the new modeling. The modeling showed lower water surface elevations, meaning there were less benefits, but also that the dams could be reduced in size, and therefore also reducing costs. This resulted in the proposed Birch Creek Dam being reduced by a total height of roughly 10 feet and reduced the inundation area upstream of the dam during a 100-year storm by almost 300 acres. You can see on the exhibit here the previous PMF boundary, again shown in brown, as was shown earlier, and the optimized PMF boundary in the teal color. Based on these reductions, there is a cost savings experienced both in the construction cost of the dam as well as in the cost to acquire the land needed across the inundation area. The project cost range for the master drainage plan that I mentioned earlier showed the difference between obtaining land up to the 100-year inundation limits or the PMF limits. In order to ensure that no structures would be built in the areas upstream of the dams that could be inundated, it would be recommended that at least an easement be acquired by the project sponsor all the way out to the full PMF limits. Similarly, the proposed Walnut Creek Dam was reduced by roughly 12 feet in height and nearly 500 acres in 100-year storm inundation area. And again, you can see the difference between the initial PMF limits and the optimized PMF limits. In addition to these size and cost optimization efforts, our consultant utilized the FEMA Benefit Cost Toolkit to recalculate the benefit cost ratios for the dams. The FEMA Toolkit includes consideration of a relatively new type of benefit being considered by the federal government, known as social benefits. These benefits look beyond simple structural protection to impacts such as lost work productivity and mental health following natural disasters. Utilizing these social benefits in addition to typical structural benefits, our consultant calculated benefit cost ratios of roughly 2 and 1.9 for Birch and Walnut Creeks, respectively. As you'll see at the bottom right of the slide, the cost for building both dams is estimated at $179 million, and the benefit cost ratio for the combination of both dams would be less than the two individual dams at just over 1. And just for reference, the total costs shown on the slide include construction, environmental mitigation, land acquisition, as well as engineering and design. This exhibit shows the location of future predicted damages in the Spring Creek watershed, with the expected concentration of damages increasing from purple to red to yellow, with yellow being the highest concentration. And the next two exhibits show the locations of structures that are anticipated to be benefited by each of the proposed dams. This exhibit shows the structures associated with Birch Creek. There are a total of almost 8,700 structures estimated to experience reduced flooding impact to some degree, and some of which that would be completely removed from the floodplain. And here are the structures predicted to benefit from the Walnut Creek Dam. The total number expected to experience some level of reduced flooding impact is very close to Birch Creek at almost 8,700. For comparison, the structures estimated to benefit from a combination of both dams is a bit higher than the two individual, but not by a large amount, explaining why the combined benefit cost ratio was lower than that for the individual dams. While the last two slides showed benefited structures, this slide shows anticipated water surface elevation reductions at various points on Walnut Creek and Spring Creek. If you live along the creek and have experienced flooding in the past, these numbers may help you better visualize the potential benefits of the dams. And you can see there are benefits of up to roughly 3 to 7 inches as far downstream as I-45. Going back to our list of challenges, we feel we may have overcome the second issue based on updated benefit cost ratio calculations resulting in numbers greater than 1, at least from a federal tool perspective. Our consultant is working through additional calculations using a tool provided by the Texas Water Development Board. While it appears that tool may result in lower ratios than the FEMA tool, the cost of the dams means they would likely require at least partial federal funding to complete, and we believe our current FEMA estimated ratios of around 2 should put us in a good position to obtain funding from federal sources. We also don't know yet how the state will utilize benefit cost ratio in the selection of projects for funding. We will continue to evaluate the feasibility of the projects from a benefit cost standpoint, but don't believe there is a fatal flaw at this time in that regard. The second challenge is the study team discovered the existence of 2 planned major developments in the same locations as the proposed dams. This issue is yet to be resolved and is the next major item we need to address in the study. One conflict discovered is a large residential development planned at the Birch Creek Dam location, with approximately 300 acres of development included in the currently proposed inundation area. Our goal is to coordinate with the landowners and/or developer to hopefully come up with a mutually beneficial solution that would allow the proposed dams to be constructed alongside the development. The dam could provide detention volume needed by the development, and the inundation area could be used for amenity items such as soccer fields, walking trails, or general park space due to it being dry most of the time. The challenge at the Walnut Creek Dam site is more difficult to overcome. A large solar farm is proposed at the site with approximately 100 acres of solar panels, or roughly 14% of the total panel area estimated to be within the proposed inundation area. This project is further along than the residential development, as some minor construction efforts have already begun. While it may be too late to come to a mutual solution at this site that would involve adjusting the solar farm design, it may be possible to adjust the dam location or size to avoid impacts to the planned solar construction and still coexist at the site, providing an opportunity for green energy infrastructure and flood reduction all in one. Based on the results of the study to date and the challenges experienced, we want to hear from the public and other stakeholders to determine the level of support for the Spring Creek flood control dams being analyzed as part of this study. Following this public meeting and other outreach efforts, our goal is to coordinate further with the developers and landowners of the properties to determine the feasibility of working together towards solutions. Ultimately, a determination of the feasibility of the project as a whole will have to be made. So we want to hear from you. We value your input. And again, we very much appreciate your interest in this study. If you have any questions or comments, please visit the Contact Us page of the project website at www.springcreekstudy.com. Thank you very much for your time.